Assalamu alaikum and good evening, everyone. Today we are going to start 0620 alternative to practical October-November 2023. A student uses a chromatography to analyze samples of three different dyes. The apparatus the student uses shown in figure 1.1. Okay. A spot of each dye is placed on the paper and some ethanol is poured into the beaker. Draw on 1.1 three spots to show where the three dyes are placed on the paper at the start of the experiment. So you are going to put the three spots like this on the baseline. Okay. Then a line to show the level of ethanol in the beaker at the start of the experiment. So this line must be like this because the solvent is always uh, below the baseline. Okay. So after this B part, during the experiment, the ethanol moves up the paper. State when the student should remove the chromatography paper from the ethanol in the beaker. So it is, ethanol starts to rise up in the beaker, and when it reaches almost at the top, we will remove it. No, it's not necessary over here. So uh, it is removed when ethanol is almost at the top of paper. Okay. Now, figure 1.2 shows the result of the chromatography experiment. State what conclusion can be made from the results. So it's of 2 marks, right? So one conclusion would be that dye 1 and dye 3 are pure substances. Very good, Zainab. Dye 2 is a mixture of dye 1 by 3. See, because if you see this distance and this distance, so it means dye 2 is basically a mixture of these two dyes. Because we are getting one spot only, so it means it's a pure thing. If it's not pure, then we are getting the multiple spots. The components would be separated in the chromatography, right, Heather? Okay. Now question number 2. Copper 2 carbonate reacts with dilute acid to make carbon dioxide. Okay. We know this reaction, right? A metal carbonate with the acid. We will get copper chloride, carbon dioxide, water, and carbon dioxide. Yes, here it is. Okay. Now, experiment 1. Use a measuring cylinder to pour 40 centimeter cube of dilute ethanoic acid into a conical flask. Okay, 1 minute. Malachite is a mineral that contains copper 2 carbonate. Investigates the rate of reaction between powdered malachite and dilute ethanoic acid. At different temperatures, the student does 6 experiment. Okay, they have seen dilute ethanoic acid. So it is going to be CH3 COOH. And here we are going to get CH3 COO twice Cu plus H2O. So twice of CH3 COOH. Okay. Using a measuring cylinder to pour 40 centimeter cube of ethanoic acid into a conical flask, warm the dilute ethanoic acid about 5 degrees Celsius. Measure the temperature of the acid using a thermometer. Set the apparatus up as shown in figure 2.1. So see, this is figure 2.1. So here we are going to collect the gas and we will record its volume. Okay. Now what they are saying, this is bung, you can see. Remove the bung from the conical flask, add 1 gram of powdered malachite to the conical flask, replace the bung and start the stop clock. Record the time taken for a 100 centimeter cube of gas to be collected in the measuring cylinder. So see, when you have to start the stop clock and you have to stop when 100 centimeter cube of the gas has been collected. Empty the conical flask and rinse it with distilled water. Okay. In experiment 2, repeat experiment 1 but warm with 10 degrees Celsius. So see over here, it's 5 degrees Celsius. We did with the 10 degrees Celsius, rest of the things are fine. In experiment 3, it is repeated with 15 degrees Celsius. Experiment 4 repeated with 25 degrees Celsius. So every time we have increasing the temperature, right? Okay. Now what they are saying in the iPad, use the thermometer and the stop clock diagrams to complete table 2.1. Okay. So in experiment, what is the temperature? If you see, it's 26.5, right? If you see over here, it's 31.0. If you see over here, it's 36.0. If you see over here, 40, 41, 42.0. If you see over here, it's 53.0. And it's between 59 and 60, so it's 59.5. Is this understandable to all of you? Now, see, if you see over here, how many minutes have been passed? 4. And after 4 minutes, how much time is passed? 35, 36, 37. 37. So 4 minutes means 4 times 60, and 4 times 60 is going to be 240, and 240 plus 37. So no, sorry, it's 42. So 282. So I'm going to write over here 282 seconds. Now, if you see, the temperature has raised over here, right? So again, 4 minutes for 4 times 60 makes it 240. And no, there is no range. It's very specific. Yeah, it's 3. Thank you, Zainab. So 3 times 60, it's 180. And after that, 15 minutes. So 180 plus 15, 190, 195 seconds. Yes, very good, Ahmed. Now, if you see 2 minutes, so 2 times 60, 120, and it's 28. So it is going to be 148 seconds. So see, as the temperature is raising, the time to collect the 100 centimeter cube gas is decreasing. So it means it is collecting in a lesser time, which means the rate of the reaction is increasing. Now see, 1 minute, which means 60 seconds, and then 45, 50. So total 110 seconds. Then 1 minute and 5 seconds. So 60 plus 5, 65 seconds. And over here, if you see, 0 minute and 44 seconds. So is this clear to all of you? Okay. Now complete the suitable scale on y-axis and plot the results from experiment 1 to 6 on figure point 2.2. Draw a line of best fit through your points. Okay. So we have how many boxes? How many big boxes? 1, 2, 3, 4, 5, 6. And on y-axis, we have a volume. Time taken. Okay, so the maximum time taken is 282. So it means I need a 300 over here. So what if I kept 150, 200, 250, 100, and 50? Okay. So at 26.5 degrees Celsius, it's 282. Okay. Now, yes, where were we? 26.5 degrees Celsius, 282. So 26.5 is this, right? And we need a 282. So 260, 270, 280, 290. So it's 280, 285. So 282 is must be over here. Okay. Then at 31, 195. So 31, 195. So 190 and 195. It's over here. Now 36 and 148. So 36, 148. So 140. So 148 is almost over here. Okay. Then we have 42 and 110. So 42 and 110. Right? Then we have 53 and 65. So 53 over here and 60, 65. Yeah. Then we have 59.5 and 44. So 59.5 and 44. So it's going to be over here. Is this understandable? Now what they are saying? Best fit line. So see, this is how we are getting the best fit line. All the points are on that curve, right? Okay. Now, the average rate of an experiment can be calculated using the equation average rate the volume of gas collected, time taken to the gas. Use this equation to calculate the average rate in experiment 3. Give your answer to the rate you have calculated. Okay, let's have a look at experiment 6. Okay, so let's have a look at experiment 6. Volume of a gas collected is 100 and the time taken is 44, right? So we will calculate 100 over 44. So the unit would be centimeter cube. Sorry, centimeter cube per second, because time is in the numerator. Can anyone calculate the average rate? But it's not going to be like the straight line, because it's not, the rate is changed dramatically, not with the exact proportion. Whenever you see the curves for the rate, they are always curved, not the straight lines, okay? So we are getting 2.27. Reduce in which experiment 1, 2, 3, 4, 5, 6 the rate of reaction is greatest. Okay. So if you see in all of them, we are collecting 100 centimeter cube. And this one, the experiment 6, yes, very good, Rahim. So the experiment 6 takes the lesser time, so the rate would be greatest in experiment 6 only. Is this clear to all of you? Okay. Now part D. Extend the line on your graph in figure 2.2. Reduce the time taken to collect 100 centimeter cube of gas when the temperature of ethanoic acid is 65 degrees Celsius. Show clearly figure 2.2 how you worked out your answer. Okay, so we have to extend the line. So if I extend it, so at 65, if you guys will see, the gas is it a 40, 10, 20, 30? No, it's a 30 seconds, right? So it's 30 seconds. Now, the 40 centimeter cube of ethanoic acid is used in each experiment is measured using a measuring cylinder. Measuring cylinders are available in the following sizes. Draw a circle around the size of measuring cylinder, which would be most suitable to measure the 40 centimeter cube of ethanoic acid. So obviously, if you have to measure the 40 centimeter cube of ethanoic acid, so that is the most appropriate one. Okay. Because it's for approximate. So if you use the 100 centimeter cube for a 40 to measure the 40 centimeter cube, it's approximate. So the variation of the reading will be very high. How could you use 25 centimeter cube to measure the 40 centimeter cube ethanoic acid, Rahim? You have to use it twice, once 25 or twice, 2 times 20 centimeter cube and 20 centimeter cube. Okay, now part F. Most of the gas collected in the measuring cylinder is air rather than carbon dioxide. Explain why it's collected in the measuring cylinder. It's obvious because that air is present in the flask initially, right? If you see over here, and that air is first moves and displaces the water. And carbon dioxide actually push that air to move out. So as carbon dioxide formed, it pushed the air out of flask. That's why it is collected in measuring cylinder. Is this understandable to all of you? Explain why this does not affect the accuracy of the result. Yes, it's very easy because both are at the same temperature. So the volume of air displaced equals the volume of carbon dioxide. Both have a same volume, so that's why what the amount of carbon dioxide formed in the flask, that same amount of air is going to be, collected in the gas syringe. So there will be no accuracy or no inaccuracy, basically. Now G part. During the reaction, each experiment, the temperature of the acid decreases slowly. Give a reason why the temperature of the acid decreases and suggest a change to the apparatus used to minimize the decrease in the temperature. It is because of a heat loss. That is very simple, right? That heat lost to surrounding. That's why the temperature is being. No, we can't use vacuum flask. It's very simple, Khatija. If you see over here, right now, there is a air over here. So when the carbon dioxide forms, so the air from here moves to this area. So whatever the volume of air collected over here, that the equal volume of carbon dioxide is there. So that's why the same volume is displaced and move out of the flask. So that's why there is no inaccuracy. Okay. So heat loss to the surrounding and how we can, yeah, we can insulate the flask. Yes, very good, Zainab. Or you can place in the water bath as well. Flask, or instead you will write that keep or place it in water bath. So in the water bath, we can control the temperature, right? Now, question number 3. The student has two substances, solid M and solid N. The solid test on solid M. Solid M is hydrated chromium 3 nitrate. Complete the expected observations. Okay. The student places half of the solid M in a boiling tube and heat it strongly. The student holds the piece of anhydrous copper to chloride paper at the mouth of the boiling tube. Okay, so see, this is what we have discussed in. No, white to blue is with a copper 2 sulfate. It's cobalt 2 chloride. It changes from blue to pink. Now, second part, the student inserts a glowing split into the mouth of the test tube. The splint bursts into the flame. Identify the gases given of heating solid M causes this result. It's a glowing splint, so it means it's a oxygen. Oxygen in oxygen, it catches the flame. Yes, you can write O2, not O. The student dissolves the remaining solid M into the water to form solution M. The student adds aqueous sodium hydroxide dropwise, then access to solution M, observation adding dropwise. So it's a chromium 3, right? So for chromium, if you guys remember, that's fine. And if you not, then you must see from the table and the end, the green precipitates would form. And in excess, the chromium's green precipitate dissolves in sodium hydroxide. Yes. The student adds a piece of aluminum foil to the product from B1. Okay. The mixture is then warmed. The student tests for any gas product. So see, it's a nitrate. That is the test for a nitrate. So the gas is formed, and that the test is damp red, litmus turns blue. Yeah. So they are asking for the observation, right? So we can write that the damp red litmus turns blue as gas formed. Yeah, they didn't ask for the gas. Remember, they asked, see, read the question again. They didn't ask for the gas. You know that it's ammonia and they are asking for the test, the observation of the test. So you will write the observation for the test. It's soluble in excess, Shamir. Check it from the table. That is a chromium ion. See over here. Green precipitate soluble in excess. In aqueous ammonia, it's insoluble. Okay. Now test on solid N. Table 3.1 shows the test and the student's observation for solid N. Do a flame test on solid N. Light green flame. So if you recall the light green flame, what I remember, it's for barium ions, right? Dissolve the solid N in water to form solution and divide the solution N into 4 pages. Yeah, with the iron 2 positive, it's insoluble. To the first portion of N, add dilute sulfuric acid, white precipitate. So on adding dilute sulfuric acid, white precipitates are formed. It also confirms the barium because barium ions gets precipitate out with the sulfate ions. So sulfuric acid is providing the sulfate ion. Test 3. To the second portion of a solution N, add about 1 centimeter cube dilute nitric acid followed by a few drops of aqueous silver nitrate, pale yellow precipitates. So if there are pale yellow precipitate, it might be a possibility that there is a iodide ion. To the third portion of a solution N, it's a test 4. Add about 1 centimeter cube of a dilute nitric acid followed by a few drops of aqueous barium nitrate. No visible change. So it means no sulfate is present, right? No sulfate is present. Because on adding barium nitrate, if we get the white precipitate, it's either sulfate or a sulfide. To the fourth portion of a solution and add about 1 centimeter cube depth of aqueous chlorine brown solution. Okay, so yeah, it means that chlorine is displacing and the solution is brown, which means that see the iodide is there, which iodide turns into iodine as the chlorine displaces. So if this is the brown solution, so the reaction would be like this, that the chlorine reacts with the iodide ions, forming chloride and iodine is formed. That's why we are getting the brown solution. Is this understandable to all of you? Okay. Describe how to carry out the flame test. Flame test on a solid, right? So take solid crystals of N on wire loop, put it on blue flame, right? So the observation is there. Identify solid N. So we identified that solid N has a barium ions. Further, we have identified that it has a iodide ions. So it must be barium iodide. See, is this clear to all of you? Yes, very good, Zainab. See, Ahmed Mustafa, the flame test is performed on a solid N. Then we have made the aqueous solution. Yeah, nichrome is also taken. Now, question number 4. Grease away and kitchen clean are two solutions used as a household cleaners that contain aqueous ammonia. Plan an investigation to find which of the two household cleaners contain aqueous ammonia with the highest concentration. Assume that aqueous ammonia is the only alkali in the cleaner. So see, we can use the we can do the titration with the same concentration of a hydrochloric acid, for example. So the one having a more concentrated will use more volume of a hydrochloric acid, and the other one will take the lesser volume of the hydrochloric acid if it's diluted. Okay, so it's easy, you know. Uh, we will start with like this pipette out, 25 centimeter cube of grease away, let's say, with into a conical flask. Add, which indicator we are using? Thymolphthalein, right? What you want to explain? What you want me to explain again? Yes, see, just just I am telling you the step, then you will understand it. Otherwise, I will repeat. What I did, I take out the grease away because you know it's an alkali and we have to identify which alkali is more concentrated, whether grease away or kitchen away. So we will do the titration because alkali can be titrated with an acid, right? So we will go for the titration. So fill the burette with acid of known concentration. Till here, is this clear to all of you? Now add acid to the flask containing grease away. Slowly to get the correct endpoint, or to get the correct endpoint means when the color is actually get changed. Till here, is this clear? Now record the volume of acid by taking initial and final volume reading from the burette. Okay, till here, is this clear to all of you? Now think, some specific amount of acid has been used. Now repeat the experiment. Now repeat experiment with 25 centimeter cube of kitchen clean and keep the rest same. See? So now in both the cases, the volume of acid used must be different. So the one which consumed the greater amount of acid is the one having more concentration of ammonia in it. Is this understandable now? Which consumed more volume of acid has greatest concentration of ammonia. So see, that's how you will able to write the answer. So we are done with this paper. And now tomorrow we will have a class, and then no, it is we continuously adding the acid till we get the end point, isn't it? It's not exactly the volume of a base. We are adding the acid from the burette. So we will continue to add it until the color changes. So obviously, if both have a different concentrations, so both the kitchen clean and the grease away both have a different number of moles of ammonia in the same volume. So the one which has a more number of moles are going to use up more, hydrochloric acid. So which shows that this one is having a greater concentration of ammonia. Okay. Okay, so see you everyone tomorrow. Take care. Goodbye and Allah Hafiz.